Climate variability includes all the variation in the climate that lasts longer than individual weather events, whereas the term climate change only refers to those variations that persist for a longer period of time, typically decades or more. In the time since the Industrial Revolution, the climate has increasingly been affected by human activities that are causing global warming and climate change. Burning fossil fuels produces carbon dioxide, a greenhouse gas. It is called a greenhouse gas because it produces a greenhouse effect. The greenhouse effect makes the earth warmer just as greenhouse is warmer than its surroundings. Carbon dioxide is the main cause of human-induced climate change. It stays in the atmosphere for a very long time. Other greenhouse gases such as nitrous oxide stays in the atmosphere for a long time. Other substances only produce short-term effects. Not all substances produce warming. Some, like certain aerosols, can produce cooling. Human activity is the main cause of climate change. People burn fossil fuels and convert land from forests to agriculture. Since the beginning of the Industrial Revolution, people have burned more and more fossil fuels and changed vast areas of land from forests to farming land.
Atmosphere is a mixture of gases. Some are known as greenhouse gases. That's because they trap heat from the sun and warm the earth. That's good, because without greenhouse gases, our planet would freeze, and life as most of us know it would be impossible. These greenhouse gases, mainly water vapor and carbon dioxide, naturally cycle between the land and atmosphere and ocean. And over the ages, these greenhouse gases have reached a delicate balance that results in temperatures that we like a lot. It's been that way for thousands of years, until the last 150 years. That's when people began burning fossil fuels. Those fossil fuels, coal, oil, natural gas, contain carbon that's been locked away from the natural cycle for eons. But when we burn them, that carbon joins with oxygen to make carbon dioxide that goes into the atmosphere. It throws the natural balance out of whack. The more carbon dioxide in the atmosphere, the more heat that is trapped, and the warmer it gets. And the warmer it gets, the more the climate changes, and the higher the ocean will rise. The more we learn about carbon dioxide and other greenhouse gases, the better we can deal with the changes caused by global warming, because good planets are hard to find. When you think of NASA, you probably think of astronauts, satellites, Mars rovers, and telescopes that study distant planets and far-off galaxies. So why does NASA as a space agency study Earth? Because it's a planet too, and there are a lot of advantages to monitoring the only home we currently have, from space. Just 3 years after the space age began, NASA launched the first satellite to monitor Earth's weather. It was the beginning of a revolution in weather forecasting and laid the foundation for the global study of Earth. Today, NASA's fleet of Earth-observing satellites is essential to helping us understand how our planet works. We're trying to answer some very big questions. How is Earth changing? What's causing these changes? And what does the future hold? The answers are critical to human life and civilization as we know it. Adding to what we learn from satellites, NASA also makes regional observations from airplanes and ships. Our scientists collect even more data on the ground, and others use computers to model what's happening now and in the future with the land, ocean, and atmosphere. Altogether, it's called Earth System Science, and NASA is a global leader in the field. Best of all, NASA shares what it learns with researchers and agencies throughout the world. Because when it comes to understanding Earth, Space is the place to really know a planet. And that's exactly where NASA is.